the example that the mean marks of 100 students is mean value is 70, median value is 65, and mode value is 60. So it is good or bad for the class performance. On the basis of mean means total marks divided by number of students. Median marks means the marks half number of students have got less than this and half number of students have got more than this. This is a 65. And mode means the marks which has the highest frequency. So most of the students have got 60 marks. So it is good or bad? It is not good because mean marks is 70 marks, and most of the students have got 60 marks. 60 means mode marks is 60 marks. That is saying that due to few students, some students have got high marks. Some students have got 95, 98 marks, and due to this, the mean marks is increasing. But the reality is that most of the students is getting the marks 60. So this is the not good. In the case of India also, when you calculate the average income, per capita income, the mode income is very less than per capita income. Means due to the high income of only some people, the mean income is per capita income is high. So this is not good. Means disparity is high.
Sir, in your screen.
Yes. What, sir? The screen is visible? Yes. I'm not listening you. Please unmute yourself.
Statistical tools and statistics. That slide is displaying in our screen.
Yes. In the statistics, I'm discussing the statistical tools.
Okay,
Okay.
sir. Okay, sir.
Yes. So measures of how much we can believe on the measures of central tendency. Measures of central tendency in the mean, it is affected by extreme value. Suppose there are only in the case of India, 20% rich people of India have 80% income of India. So on the basis of average marks, we cannot know the exact situation. Therefore, we need the second degree. Second degree is dispersion. Dispersion is stating that from the mean value, the values of individual marks is far away or less. And in the measures of dispersion, standard deviation is the best because it is based on all data. When the value of standard deviation is high, means the data is heterogeneous, means different types of data. Heterogeneous means very variation in data. And when value of standard deviation, dispersion is 0, means data is homogeneous. Suppose that we take the example of 500 people, and we have written the income of 500 people. The income of all the people are same. The value of this person will be 0. The value of standard deviation will be 0. Means the people are homogeneous, same attribute. But if the difference in the value is very high, some person has very high income, some person has very low income, then the value of this person will be high, and it is telling that all the people are not the same. Okay, I'm saying that suppose there are 500 people in a village. You are going to study the prosperity of 500 people in a village, and 490 people, their income are 10,000, 11,000, 9,000, like this. 499 people, the income is 10,000, 20,000, 15,000, 12,900. And one person, only one person income is suppose 5,000 crore. One person income is 5,000 crore. Then the average income will be very high due to the one person income. And on the basis of mean, mean income, average income, we can say that all the people are rich. Here statistics is good servant or the bad servant. This statistical calculation is good or bad? Bad.
So
Due
when
to the one person very high income, we are saying that 500 persons are rich due to the extreme highly income of one person, while another person's income are 10,000, 20,000, 50,000, they are not rich, but we are saying that they are rich because due to one person high income, the average income is very high. So what we should do? How can we know that mean is demerits, measures of central tendency has demerits or not? By knowing this, we apply the second degree, dispersion. In the dispersion value is more means from the average value, the deviation of the income is high. And dispersion value 0. Suppose we calculate the standard deviation is more appropriate in this. Suppose the dispersion value is 0 means all people income is 10,000, 10,000, 10,000. All persons income is 10,000, 10,000. This person will be 0. You can calculate range, mean deviation, standard deviation, all will be 0. So we can calculate by this. So when dispersion is high, so dispersion is high, but in the left side or right side. All the data lies in the left side or right side. By knowing this, we apply the third degree, skewness and kurtosis. By knowing this, we apply skewness and kurtosis. Mean is most of the data is below the average data or more than average data. If most of the data, most of the person income is more than average income, it is good. But most of the person's income is less than average income, it is bad. In the case of per capita income in India, the income of most of the people is less than average income. Mean due to the few people's income, the average income is high in India, while most of the people income is low, and this is not good. When most people's income is low, of course, the consumption will be low, investment will be low, saving will be low, and it is not good for business in the case of India. So this is the descriptive statistics. In the descriptive statistics is also two parts. One part is visualization of data. Visualization of data, and second part is calculation. Calculation. In the visualization of data in descriptive statistics, we make the pie chart, line diagram, bar diagram, simple bar diagram, multiple bar diagram, curve diagram, we make this in the first part of descriptive statistics. In the second part of descriptive statistics is the calculation. In the calculation, we calculate the measures of central tendency as measures of dispersion as skewness and kurtosis. We calculate the skewness and kurtosis. I will teach you what is the meaning of skewness and kurtosis. I think in the next slide it is given. Second part is inferential statistics, theory of estimation. It is related theory of estimation. It is divided in two parts, theory of estimation and hypothesis testing. Theory of estimation is divided in two parts, point estimation and interval estimation. In the determinants of demand, in the determination of the level of demand, what is the role of price of the product, what is the role of consumer's income, what is the role of advertisement expenditure, what is the role of prices of complementary goods, what is the role of prices of substitute goods, what is the role of season and environment, what is the role of advertisement expenditure, what is the role of population level, individual role we calculate in the theory of estimation. We solve this by the regression model. In this, we can exact value is called price estimation. Exact role we calculate is called price estimation. And when the role is calculated in the class interval, that is called the interval estimation. And in the hypothesis testing, we formulate the hypothesis and test this. Suppose, uh, suppose there are two variables, quantity demanded and price. Then we make the null hypothesis. Null hypothesis means the hypothesis which is to be tested. There is no significant impact of price on demand. There is no significant impact of price on quantity demand. If there are two variables, one dependent, one independent. If more independent variable, then we null hypothesis. There is no significant impact of quantity demanded. There is no significant impact of quantity demanded due to independent variables. Independent variables are more, they have no impact. Independent variable have no significant impact on dependent variable. We will read this in this also again in this given in this slide. Here, in the descriptive statistics, two parts. First one is the data visualization and second one is the calculation. So data visualization is data summary, the methods of organizing, summarizing and presenting data in convenient and informative way. There are three methods. We can present the data in the tabular technique. We can present the data either in the tabular tables with the help of table. We can make the table. The example is given in the next slide. We can present due to graph. By the graph we can present. This is also good. And third one is called numerical data. Numerical technique. Numerical technique is the tabular technique and graphical technique is called tabular technique, graphical technique, pictorial picture by the picture. This is called the data visualization and this numerical, and this is the second part of descriptive statistics, which is the next slide. In the tabular technique, tabular presentation of data, one way and multi-way classification. Suppose that we have to show the population of Indian states, generally here, year and here population. This is the one-way classification. And suppose that gender-wise, region-wise enrollment of students in different year in a university. In a university, this is the data. You are doing the study of University of Mysore related to the admission. What is the gender? Gender role you are showing region-wise. In the University of Mysore, what is the condition of gender-wise admission? Region-wise admission from the rural areas or urban areas students, and gender-wise means female or male students. Enrollment of students in different years in a university, you can show by this. So you can make this table, and here you can write the year 2023, 2024, 2025, and here admission. Then here urban areas, rural areas, urban areas, here region, here gender, okay, here region. In the region we divided two parts. Urban areas, here urban areas, here rural areas. In the urban areas two parts, male and female. Rural areas two parts, male and female. Then here more of the table will be. By this methodology, we can understand the trend of data properly. That is the data visualization. You can also make with the help of diagram also. In the PhD thesis already you see this, the candidate do like this. Okay, suppose here we can make this is by the tabular, but the title of the table should be very clear, and according to The variables, according to the variables, there should be the number of row and column in the table. It is very difficult work, not easy work. When you include the more data in the table, it will be some difficult work. But by this methodology, we can present, visualize the data properly. By the graphical techniques, here I have told that the income distribution, by the graphical here income and here number of families. When income level increases, number of family is increasing. After this level of income level increases, number of families decreases, like this. So here in this is the symmetrical. Symmetrical means this. Here peak is high. So from this we divide in two parts. By this income, half person income is less and half is more. Median is also here. Median is also here. In the picture I am touching. Median value is also this. Mean value is also this. Mode value is also this. Same. Mean, median, median are same. Mean, median, mode are same. This is called the symmetrical. But here mean, median, mode are not same. Here peak is high means more number of families. Here mode is this. Mode is this. Median will be more than this. Median will be more than this. Mean will be more than this here. So mode will be left side. Mode is less. In the case of India, here mode income is this in India, medium income is in this, and mean income is in some more in this. So this is the case of India. It is not good. And here mode is high, median is the small low, and mean is low. This is the case. It is negative skew, it is positive skew, and skewness means uh, skewness tells that the data is scattered left side or right side. Most of the data are less than or more than. Here in case of income distribution of India, this figure will come. Most persons income is less than mean income. So peak is left side here. Peak is left side. And if the picture will be like this, it means equal distribution of income in the country. So you can you can take the 5 cities. You can take the 5 cities of Karnataka and you can study the income disparity. Income disparity of income disparity in Karnataka state. You can take the 5 cities and you can make that, you can collect the data and make the diagram and you can write the interpretation. In which city the income disparity is okay? In which city the income disparity is high? So you take the data of 5 cities, the picture will be also the different. This picture, you make the 5 diagram like this. You can study the income disparity of rural India and urban India. You can find the difference. Where is disparity is high? You can make this in the case of developed countries and underdeveloped countries. Developing countries, it will be this. I'm saying like this. So you can do this. Suppose that there are two classes, two sections. Income, section A, section B. And you have taken the number of students, the marks of a student, you can make like this. In the same, here diagram same makes, one is going like this and second can be like this, like this. So you can write the interpretation. So this is the case. So in the data description, we make the graph like this. This is the histogram. Histogram. This is also the histogram. In the histogram, there is no gap between this and this. Histogram, histogram, and histogram. But when you make the bar diagram, this will be gap between this and this. Gap between this. Okay, so according to the situation, you have to apply this. You will read the tabular presentation of data, that is also very important in research. You can apply this. Here, the curve diagram. Suppose that here is given. Suppose here, I am not reading what is given. Suppose here, sale is given, sales, and here month is given. Suppose I'm saying month is given and sales is given. In the different month, the sales of two products like this trend. By this trend, you can do the forecasting also. In the case of India, suppose this is the India different year, and here the birth rate and death rate. You can do like this. It will go upward, and you can make like this. So according to the situation, income, different month, income and level of consumption, you can make the two graph by the two symbols. Symbol will be different. You can do this. Here is this pie chart. What is the difference in the consumption pattern of Karnataka, Bangalore city and Delhi city? You can make the pie chart. You can take the sample of 100% from New Delhi and 100% from Bangalore, and can make the family expenditure, monthly expenditure, share of different items. So Delhi will be different, New Delhi will be different some, and Bangalore will be some different. Okay, Karnataka will be Bangalore will be some different. You divide in different parts. Foods, expenditure on foods, expenditure on education, expenditure on house rent, like this. Expenditure on cloth, others expenditure. You can make these different parts you make, and you make the two. One for the Delhi, New Delhi, and one for the Karnataka Union. And you can do the comparative. For the 5 cities of Karnataka, you can make this. For the India and Karnataka, make the two, and you can compare Karnataka with India, India figure with Karnataka. You can make this uh, America and India, USA and India pie chart of monthly consumption pattern of the USA and India, and you can see what is the difference. By this methodology, we can do the research. Okay, by this data you can see. You can make the role of primary, secondary and tertiary sector. Primary, secondary and tertiary sector in the GDP. In the GDP role, here you can do the vertical and horizontal. Suppose that 1951, you can make the pie chart of sector distribution, and 2025, 1991 and 2025. 3. 1951, 1991 and 2025. Make the three, and you can do the comparison. After the independence, at the time of independence, this situation. Within the 40 year, the changing in this. This time, the changing in this. The impact of globalization in the changing. Why it is changing? All those things you have to write the interpretation of this. And this is the aspected diagram. So by the different figures, you can make this. Okay. You can make like this pie chart. By the bar diagram, you can also make. From the different year, different bar, different items you can make. Here one another is box and whiskers plot. By this here maximum, this is the 100, this is the maximum, and this is the minimum. This is the median, middle of this. Most of the data is this to this. Okay. This is the 25, 25th means Q1. This is the 25th means Q1. This is the Q1. And this is the Q3. And this is the Q2. First quartile, second quartile is called the median. And this is the third quartile. 25%. This is the maximum 100. And this is the minimum 0. Look here, see this. Here 25. Median is here 50. Median is 50. More data. Look here. Here say 10th percentile, this value is less than 10th percentile, and this value is this. So here the data is coming. If it coming like this, point is going the out of the box. Here out of the box here, and here also out of the box. This is not good. In the case of income distribution of India, you can find this. In the case of state differences in the investment, you can find this. In the case of city development, In the India, there are many cities, but some cities are growing fast. You can find the situation like this. But if this all the point like this, all the points are coming in this, the disparity is low. And all these points are coming here, coming like here, coming here. Oh, look, 1, 2, 3, 4, 5, 6. Suppose in the case of India, all 6 points are coming here. First option is here. All 6 points are coming like the second option. And third option is all 6 points are coming here. Which one is better? Option 1, all 6 points are coming here. Option 2, like this. Option 3, all 6 points are coming like here. Which one is better? Option 3 is better. Option 3 is better. So you have to write the interpretation. Arithmetic mean, median mode, I have told you. Harmonic mean and geometric mean. Harmonic mean is used in the case of distance and time. Suppose a student is going to university at the speed of 40 km per hour and returning back at the speed of 50 km per hour. The average speed will be not 45 km per hour. Average speed is not 45. Average speed will be 44.4 km per hour when you calculate this. But if the wage of one person is 40 rupees and second person wage is 50 rupees, the average wage will be 45 rupees. Okay. So in the case of time, distance and speed, we apply the harmonic mean. In the case of population growth, share market, we apply the geometric mean to know the mean. In the population growth, suppose that the population of suppose the price of a product increases by 10% and then decreases by 10%. Is the price is same or not? Suppose the price of a car increased by 10%. After that, the price decreased by 10%. Means the price is same or not? Now the new price become to the initial price or not? Equal to this or the less than this or the more than this? Not equal. Okay.
Yes,
Suppose
sir.
the price, yes. Suppose the price is 100 rupees. 10% increase means 110. Then 10% decrease. Now the base change. Previous base was 100. Now base is 110. So 10% of 110 is equal to 11. So 110 minus 11 is equal to 99 will be. So from the previous, the price will decrease. This is the case. So such type of situation we apply the geometric mean. In the share market study, population growth study, when the basis changes, we do not use the arithmetic mean. We use the geometric mean in research. While in case of time, distance and speed, GDP growth rate. So in the case of time, distance and speed, we apply the harmonic mean. Which one is better according to the situation? So measures of dispersion, these things are coming: range, quartile deviation, mean deviation, standard deviation. Which one is best? Mean means maximum and minimum value. Absolute calculation, relative calculation. Maximum minus minimum, absolute. Relative, maximum minus minimum divided by maximum plus minimum. And percentage you do maximum minus minimum divided by maximum plus minimum into 100 you can. Range is not good because it is affected by extreme value. Quartile deviation we divide in 3 parts. Q1 4 parts. We divide the series in 4 parts. Q1, Q2, Q3. For dividing the 4 parts, we need the 3 quartiles. Q2 is the median. Q1 is the lower quartile and Q3 is the upper quartile. Q2 is the median quartile. So it is based on the value of Q3 and Q1, so it is also not good. And median is based on all the values, but if does not, but yes, based on all the value, but it is not median by mean, median mode to be calculated by all, but it ignore the plus minus. Ignore the plus minus, so it is also not good. Standard deviation, we don't ignore the plus minus. We do the square. So minus will become plus, maybe negative, maybe left side variation or right side variation. Suppose we ignore the plus minus, it will be zero. So we do the square deviation, so it is the better. So standard deviation value is zero means the data is homogeneous. Standard deviation high means the data is more heterogeneous. So this is the situation. But according to the situation, we can use this. Skewness is related to the data distribution, symmetrical or asymmetrical data. Skewness is equal to mean minus mode by standard deviation. Mean minus mode divided by standard deviation. Mean is greater than mode, then skewness will be positive, and mean is less than mode, skewness will be negative, because formula is mean minus mode divided by standard deviation. Any value of standard deviation, mean minus mode. So mean is more than mode, of course the value will be positive. And mean is less than mode, of course the value will be negative. Kurtosis is related to the pickedness of data. Pickedness of data. Pickedness means like this diagram. The peak is high. The peak is high. Peak is high means left side and right side the distance is low. Here, the peak is like this. Peak is high here. So left side, right side distance is low means all data is near to each other. Peak is low means like this. This diagram we make like this. Peak is low. So here, like peak is here low, but data is more scattered. Peak is here this. Suppose that this is a line, and distribution is like this. So here peak is low, but this area is more. The lowest value is this, highest value is this, more dispersed. In the case of India, when you make the kurtosis, the peak will be low. This variation will be high. But when we make the income distribution of developed countries, the peak will be high, and this will be the peak like this to this, the peak will be high, and this like this. This minimum and maximum will be low. You can do this. So in the case of India, we can also calculate of different states, different cities, in the different districts of Karnataka, you can also do the study like this. Correlation, I am teaching very brief of all those things I have to cover. Correlation means relationship between two variables. Degree and direction of relationship. Degree and direction. Direction means if there are two variables, this is two. One is increasing, another is also increasing. Both are going in the same direction. By this, both are going in the opposite direction. By this methodology, this is the price and this is the demand. Both are going in the opposite direction. Negative correlation. And both are going in the same direction, positive correlation. Both increase, both decrease. Both increase, both decrease. One increase, another decrease. One decrease, another increase. Price and demand relationship generally is like this. One increase, one decrease, another decrease. But consumption and income and consumption, level of consumption. Income increase, level of consumption also increase. Income decrease, level of consumption decrease, like this. Income and saving. Income increases, saving increases. Income decreases, saving decreases, like this. This relationship. Okay, so this is the correlation case. In the case, so this is the direction of relationship. Direction tells that the variable are moving in the same direction or opposite direction. And calculate the rate. Rate means the value of correlation lies between -1 to +1. Lies from -1 to ranges from -1 to +1. Plus means positive relationship moving in the same direction. Minus means negative relationship moving in the opposite direction. This is the case. Opposite direction. So we make the simple correlation means correlation between two variables, and multiple correlation more than two variables. The correlation can be linear and non-linear. Correlation is positive but going in the straight line. A straight line. The correlation is positive but moving as a curve, not a straight line, non-linear. Negative or positive moving in the same direction, linear or non-linear, and the value of this correlation is suppose positive and 0.90 means very high correlation. So positive but low correlation 0.10, low correlation. Okay, low correlation. So low correlation, high correlation, very high correlation, very low correlation, moderate correlation. There are different classifications. So according to this, you can do the analysis and interpretation in the correlation. A regression. Correlation is telling the degree and direction of relationship, but not telling which is the result and which is false. Suppose that there is correlation between price and demand, but demand is dependent variable or price is dependent variable. Price is determined by demand or demand is determined by price. We are not knowing this, so we can do this study by the regression. It makes the function. Demand is the function of price. Quantity demanded is the function of price. Y is equal to alpha plus beta 0 x. Y is price and x is demand. You can write the regression function. So simple regression function, multiple regression function, logistic regression function, R square, the coefficient of independent variable. This is the summation is called the R square. R square high means R square is called coefficient of determination. The change in dependent variable, how much percentage has been captured in this model. This is the R. Suppose R square is 0.9. The value of R ranges from 0 to 1. Suppose here in the case of correlation, R is equal to 0 means correlation is 0. Here, look this here. One is constant, another is increasing, decreasing. One is this is the constant, no increase, and this is increasing, decreasing. This is the constant, and this is increasing, decreasing. No impact, no impact. This increase or decrease, it is the constant. So R is correct here, and both are increasing same rate. Same rate increasing, same rate decreasing. Same rate increase, same rate decrease. The R will be 1. Maybe okay. And same rate 1 increase, same rate 1 decrease. Same rate like this. Rate is same. So R will be 1 but minus. Direction is minus. And here in the case the R square means suppose we make the demand function and our independent variable is price of the product, dependent variable is demand of the product, independent variable is price of the product, advertisement expenditure, consumer's income, and R square is coming 0.8. 0.8 means 80%. Means 80% change in the demand is due to only 3. When value of R square is high, we consider that the model is fit. When the value of R square is low, we consider the model is not fit. Here factor analysis. In the factor analysis, we divide in many parts, divide in many factors. Generally, it is used when many variables affecting. Suppose that in the demand of the car, we make the different factors, technical factor, price factor, income factor, like this. Layout factor, we make 4-5 factors. And all factors related to the comfortability of the car include in this factor. So we do like this. It is some difficult, more class question to this. Discriminant analysis, we do the discrimination. Two product, car prepared by company first car prepared by company. Second, we do the discrimination. Which one is better? On the basis of price, on the basis of mileage, on the basis of price, on the basis of mileage, on the basis of layout of the car, on the basis of color of the car, on the basis of comfortability. We do the discrimination. And then we understand, then we decide that which is the better, we write the interpretation and we take the determination. So here, population, statistical decision making, we see the population. Population means area under the investigation. Suppose that we are interested to study suppose we are interested to study the investment in Bangalore city. So Bangalore city will be the area of investigation. So this is called the population. 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 And this individual is the person of the Bangalore city. Person. Unit of population. Maybe the person, maybe the family you can also make. Family 1, family 2, family 3, or maybe the person 1, person 2. So suppose that this is person 1, person 2, person 3. These are the part of population. These are the parts of population. Okay. So this is that. And suppose here sample. Sample is a portion of population which is drawn from the population to estimate the population parameter. Suppose that we are interested to know the investment pattern of the Bangalore city. So there are many persons in the Bangalore city. If you do the survey, if you take the data from all persons of Bangalore city, it is called the census method. Complete enumeration of the population is called the census. And partial enumeration, partial investigation of the population means 100%, 200%, 300% data we collect from the Bangalore city. This is called the sample study, sample study. Okay. So population has a parameter. Parameter means a statistical measurement of population. Like population mean denoted by this, denoted by mu. Population standard deviation denoted by sigma. Population proportion denoted by capital P. Population correlation denoted by rho. Population regression. Here, this is a sample. Suppose that in Bangalore cities, suppose 50 lakh people live. So population is 50 lakh. Out of 50 lakh, we have taken the data of 500 people. So sample size is 500. We study the 500 persons investment pattern, and on the basis of this, we estimate about this population. So statistic, statistic is the statistical measurement of sample. Sample is a small part of population, a small portion of population which is drawn from the population to study the population. Suppose that in the Bangalore city 50 lakh people live, 50 lakh. It is not possible to study the 50 lakh people in the Bangalore city, and therefore we can do this, we can take. Okay, so I'm saying that in Bangalore city, the population is suppose 50 lakh. So it is not possible to take the data from the 50 lakh. So we do the sample method. Sample. A small portion of population we draw to study the population. So suppose that we drawn the 500 person. So sample size is 500, and suppose population of Bangalore is 50,000 person living. 50 lakh person live in population in Bangalore city. So capital N means capital N. It is 50 lakh. A small n sample size Sample size is 500. So 500 person we take and we ask them what is their income, their consumption, their saving, their investment, all the all the things we know according to the objective of research and to the research. Then population means denoted by X bar, population standard deviation denoted by a small s, population proportion denoted by a small p, population correlation denoted by a small r, sample deviation and sample not population. Sample mean sample mean denoted by X bar, sample standard deviation denoted by a small s, sample proportion denoted by a small p, sample correlation denoted by R, and sample regression function like this. We can make this. So population regression function making is very difficult. So we make the sample regression function. So I'm saying that in research we infer about a population parameter based on statistics. On the basis of uh, statistic calculation, we know about the parameter population. Sample, we study the sample and on that basis we understand the population. When we make the hypothesis about population, you make the hypothesis about population, but you test the hypothesis with the help of sample. Suppose that a student is writing the thesis, a scholar, and he is doing the study of Bangalore city. So he is making the sample, he is making the hypothesis for Bangalore city. But hypothesis is testing by sample. He is taking the data of 500%. On the basis of the data of 500% from the Bangalore city, he is testing the hypothesis that is related to the population. Hypothesis is related to the population, but we test the hypothesis based on sample. Because population study is very difficult, very costly, time consuming. More time will take, very costly. This is the census method. It is the exact. But by the sample, the error will be, but how we can decrease the error of the research? When we increase the sample size, the cost of research will increase. The time of research will also increase, but the accuracy of research will what? Increase or decrease?
Increase, sir.
Increase, sir.
Increase, yes. But when we take a small sample, the cost of research will decrease, time of research will decrease, but accuracy will also decrease. So a good researcher is that who take the appropriate sample, appropriate number of samples. There are many formula to calculate the sample size in the Kothari formula that particularly depends on the level of significance. Level of significance. It is a very important. Level of significance is the maximum possibility of the rejection of null hypothesis. Suppose level of significance is 5. 5 means our confidence level is 95%. 5% we have fear that our null hypothesis will be rejected. 5%. So level of significance, suppose 1% means a level of significance 1% means confidence level 95 and 99%. Okay, when level of significance is low, suppose level of significance is low means the level of confidence is high. For making level of confidence high, you have to increase the sample size. This is the case. And when you increase the level of significance, the level of confidence decrease. Therefore, you can take the less sample size. And here, sample should be real representative. Suppose that in the same Bangalore city, 3 persons are doing the research on the same topic. Same topic. The accuracy, the 3 persons result will be same or not? Not same. They will be different. A small differ because the sample size they have taken the different. Suppose you are looking three researchers, one, two, three. They are the three researchers, and they have taken the 500 people or the doing the same topic from the Bangalore city. Different people, 500 according to your idea, your experience. Okay, your intuition. You are taking the sample 500. The result will not be same because not the same people you are taking. Suppose that one person is very experienced and he is taking and his sample taking idea is very good. He is taking the representative samples, his or her result will be good, better. So a study design, what is your study design? The data is suppose in the Bangalore city, the people's income is homogeneous or heterogeneous, male, female. You have to divide the Bangalore city in different parts based on the development. On the basis of population, what is the percentage of population in the Bangalore city? Suppose female is 50%, 250 from female, 250 from male. To divide the Bangalore from different area. Suppose five type of area are in Bangalore. From all five area you have to take the data on the basis of the cost. Otherwise your result will not be good. Suppose you take 500 people from the developed part of Bangalore, of course the result will be not good. So research design is very important. Sampling method of simple probability sampling, non-probability sampling, other different types. You can study this. And sample size, what should be the appropriate sample size? By the formula you can also use and by your idea you can also use, but it is better to by the formula. Data, what type of data? Suppose the data is secondary data, you can increase the sample size easily. But data is primary data, increasing sample size is increasing sample size will increase the cost and time. So depends on this data, what type of data, quantitative data, qualitative data, primary data, secondary data. The data collection is difficult or data collection is easy. In some area, the data collection is very difficult. In some area, the data collection is easy. Suppose you are going to do the study in the Kashmir region, the data collection will be difficult. So it depends on the area in which the data collection process is easy or difficult. Some area you cannot go to collect the data. This is also the major problem. So and the data is homogeneous or heterogeneous. So when the data is homogeneous, a small data is when the data is near to homogeneous, proper homogeneous is not possible, 100% homogeneity, but near to homogeneous by a small sample, your result will be good. But data is heterogeneous, very variation in data. Of course, your sample size should be high. You are understanding? I'm not teaching fast. Okay.
No, sir, we
No,
are
sir. No, sir. We are understanding.
Justification of time period. That what is the time period of the data collection? Time period is very important. You are taking the data of COVID period and studying the business general phenomena. It will not be good. So time period and justification of time period it is very important. All justification is important. A study design, what is the justification, sample size, the justification, data justification, time period justification, analysis tools, that is the justification. You are using the proper tools or not? You are using the proper tools of research or not? By the same tools, by the same tools, by the same method, the results will be same. But by the same tools, by the same method, if the three persons are doing the individual research on the same population, the result will be different because they are collecting the different data, not the same data. If the data is same, the tools is same, the result will be same. So, validity of Tools is important. Valid tool. You are using the appropriate tool or not. The data is valid or not. The data is accurate or not. If you take the wrong data, not authentic data, of course the result will not be good. The result will be confusing, and it will mislead, and you can use the proper tools or not. Suppose the data is quantitative or qualitative and are using the multiple regression model. It is not good. In the starting lecture, I have told you here, I have here told you here, we are when we were here, we have quantitative and qualitative data we have discussed. Dependent variable is quantitative or qualitative in categorical. Independent variable is quantitative or qualitative, or all qualitative, all quantitative, mixed. So according to this, you have to change the tools. You have to change the models. Otherwise the result will not be good. So this is a very important. Point and interval estimation. Point means exact value, interval means in the class interval. This is also used. Interval estimation is also used by software, and point estimation. Hypothesis testing and test of significance. So hypothesis is what? There are two types of hypothesis. One is research hypothesis and one is statistical hypothesis. Research hypothesis, generally hypothesis is related to the conceptual research, conceptual hypothesis, conceptual research. In this, we don't play with data. By your logical thinking, logical capacity, we analyze this. By giving by this point, by this point, by this, by your own intuition, you can write this. But in the statistical hypothesis, it is empirical hypothesis. It is based on the data. We have to interpret with the help of data. So hypothesis is the tentative result of research question. By the objective of the research, we make the research questions, and hypothesis is the tentative answer of research question. Hypothesis is a very difficult topic. We can read this separate in future. So it is the tentative answer of research question. Tentative answer of research question based on literature. This is the hypothesis. So the hypothesis is two types. Null hypothesis. Null means null hypothesis and alternate hypothesis. So null hypothesis means the hypothesis wishes to be tested. Null hypothesis means hypothesis wishes to be tested is called null hypothesis. Alternate hypothesis is the complementary of null hypothesis. Complementary. If null hypothesis is not okay, then what will be? Suppose that there is no significant impact of price on demand. This is the null hypothesis. Alternate hypothesis is what? If it will not be accepted. There is significant impact of price on demand. This is alternate hypothesis. Null hypothesis is denoted by H0 or HO. So HO and no impact of price on demand means beta is 0. Beta is 0. Beta is 0 means beta is 0. No impact, means change in demand due to change in price is 0. Beta is 0. So H0 such that beta is equal to 0. This is the null hypothesis. Alternate hypothesis is that HA, it is denoted by HA or H1. HA such that beta is not 0. Beta is not 0 means what? When the null hypothesis can be written in only one form, can be expanded in one form, it is called the one-tailed test. And if it is expanded in two form, it is called the two-tailed test. It is called the two-tailed test. So beta is not 0 means what? HA1 such that beta is greater than 0. Beta is greater than 0 means demand is price is affecting the demand positively. H82 such that beta is less than 0. Less than 0 means negative. Minus means demand price is inversely affecting the price. Negatively affecting the price. Means price is increasing, demand decreasing like this. Opposite. And beta is positive means price is increasing, demand is also increasing. Price decreasing, demand decreasing. So two situations. When we expand the alternate hypothesis in two parts, it is the two-tailed test. And when we can extend only the alternate hypothesis in one part, this is one-tailed test. So in inferential statistics point estimation, statistics is what? Statistics means statistics is related to the sample. S means sample or S means statistics. P means population, P means parameter. It is good idea to remember. Otherwise you can follow. So a statistic is the statistical measurement of sample. Sample means sample proportion, sample standardization, sample correlation. And P means population. P means parameter. Population parameter. Population means a statistical measurement of population. Population means population proportion, population standardization, population correlation, population regression function. So on the basis of this, so statistics estimate the parameter. Sample estimates the population like this. So in the interval estimation, we divide the two values, lower and upper, based on the sample value. So in this interval estimation, there is two value, lower and upper, between 0 and 10, 0, 10, 11, 20, like this. Then we make this. It is not more useful for you. And research hypothesis is used in the case of conceptual research. Research hypothesis is used in the case of conceptual research. By your logic, you prove to make the hypothesis is accepted or rejected. While statistical hypothesis is empirical research. So, hypothesis in statistics is a claim or a statement about a property of the population, any attribute of population. Hypothesis testing is method to test or claim the statement. Mathematical statement is different from a statement. Okay. So type of test, one tail test, left tail test or right tail test. One. And two tail test means the alternate hypothesis can be extended in two parts. One tail test can be extended in one part. Level of significance means maximum possibility of rejection of the null hypothesis. Confidence level and plus level of significance plus confidence level is equal to 1. Level of significance plus confidence level is equal to 100%. Level of confidence is called acceptance region and level of significance is called the rejection. Okay. 5 minutes 15 minutes जल्दीबाजी है हाँ जो confirmation लेते हैं okay so uh, here p value means probability value. By p value we check this hypothesis is accepted or rejected. 1 minute we here coming some on the data only 5 minutes I will take. Not more. Okay, you class is better. Suppose that here section A and section B. We have to make the descriptive statistics. MCOM section A and MCOM section B. In section A, the marks of the students 10 students. In section B, the marks of 10 students is given. So by Excel is the good method. We can go here. Here is the data analysis part. Here in the data, you can see here data analysis. This one. Okay, if not in your laptop, then we can by the file you can do this. There is a here. So we are doing the analysis here. So we are selecting this. No, 1 minute. We are go to the data. After data analysis, we go here.
Excuse me, sir. We are not able to see what you are explaining through Excel. We can see
Yes.
only thank you slide.
Oh, not seeing? Okay, 1 minute. Okay, 1 minute, 10 minutes. 1 minute. Not you are looking the Excel?
No,
All are
sir.
not seeing the Excel or seeing? Another
No, sir.
system?
No,
All
sir.
are not seeing?
No, sir. No, sir.
No,
No,
sir.
sir. No, sir.
Okay, 1 minute. Okay, okay. Okay, okay, I'm hearing this. Yeah? Yes, yes, yes. By this method. Yes. Now, yes. Now you can see. You are visible? Yes.
Yes, sir. Now it's fine.
Okay.
Yes, sir.
Sir.
Yes, sir. Visible, sir.
Yes,
Yes.
sir. Visible.
Yes. So here, MCOM section A, 10 students marks. MCOM section B, 10 students marks. So we are doing this. Here you can see the data, and after you are seeing data analysis. Here click, then it will come. If in your laptop it is not coming, then you go by here. It is the methodology is this how you can do this. First of all, you go to the file here. After file, you can go here, here, okay. After file, here go to the option. First click on file. After that, click on option. After option, this will come. This not come, okay, this will come. Here you will go on the add-in will come. After add-in, you here select this analysis tool pack. Okay, after here, you go here, click on click on go. After it comes, then if we not select this, it is not selected, it will not come. Here it will not come. We select here, we select, and here is the solver add-in I have selected for the linear programming or mathematical tools, then do the OK. Then after doing this, maybe your computer will restart, okay, or not restart also. Then you can here check here on the data you click here, then here it will come data analysis. This will come. Otherwise, you can do by this methodology. In my laptop, it is already installed. So here descriptive, choose the descriptive statistics. Here this one. Here this okay. Okay. Here input range means what you are taking the data. This is the input range. Suppose we take section A, section B, it will not work. So it will be take this two. Okay. Output range here, output range here. This output range means where your result will come. You want the result here, click. Your output range will be this location we are giving here. Here the date, no, here location given. The result will come here. After that, you have to do the summary statistics. Click here, and then if you want to calculate confidence level, then do this k value. But I am doing the summary statistics. Summary statistics. After that, okay. This is the summary statistics. Summary statistics. Summary statistics has come here. Look, understand this, yes. Here column 1 is what? Column 1 is section A. Column 1 is section A. This is the section A. Section A. And column 2 is section B. MCOM section B. Section B. Look, MCOM section B. Understand? The mean marks of section A is 46.4. The mean marks of section B is 59.1. Which section is better? Section B is better. Okay. Yes. And suppose this column you delete and here write section A, section B. Then you can do the confusion. I am deleting this column. Okay. Only. In this column I am deleting. Delete. Okay. Then here you write variables section A, section A, and here section B. Now you can do the conclusion. Okay. The mean marks of section A is this, section B is this. Section B is better. Standard error section A is this, standard error is this. This means this standard error. Not more is, but variation it tells about variation. Median is this, means 50% students marks is less than 40.5 and 50% marks number of students they have got more than 40.5, and here is 50% students have got the marks more than 61.5. So section B is better. Mode is 13, mode is 67. Yes, mode is here mean, and mean in section A, mean is this 46 and mode is 30. Mean most of the students is marks is less than average. Means very low marks. Some students have got very low marks like this section look here. 9 marks, 13 marks, 13 marks, 25 marks, 12 marks. Only 3 students have got the good marks. 90, 90 like this. 90, 99 one has got. Okay, it is saying like this. And here is better. Section B is better. The standard deviation in section A is high, section B is low. Means in the section A, the variation in the marks is very high. In section B, the variation of marks is low. So B is better. Sample variance means uh, standard deviation square, and kurtosis is negative. This is also negative. Skewness is this. Skewness is 0.28. Positive, this is also positive. And this value is this. Here high skewness means high deviation. Low skewness means low deviation. Range is, look, range is this. The difference between highest marks and lowest marks is 89 and here 57. So this is better, this is better. Minimum marks 9, minimum marks 32. So B is better. Maximum marks 98, maximum marks 89. So the topper, section A is giving the topper. Section A is giving the topper. Okay. Some total marks of section A is this 464 and total marks of section B is this students absent. This is the situation. So by this you can give the comparative analysis of marks of section A and B. You can write and you can give justification. Another sheet we are seeing. I think time is your
Yes, sir.
another class at 2 o'clock. Only 2 minutes I will take. By this demand, price, and income, we can go here. And suppose you are making the regression function. Regression function, you can go here.
Doubt.
Regression is given. Regression. Okay, regression. Suppose you are making the simple regression, input y range and x range. Y is the dependent variable, x is the independent variable. Y is the function of x. So dependent variable, demand. So take the demand only. Demand. Independent variable is suppose only price. So take only price. Only price. Simple regression function. After that, here output range select and this select, your result will come here. Simple okay do, simple regression method. If you want to calculate this, you can select this. Otherwise, simple regression model will be done. This is the simple regression model. Simple regression calculation. If you do the multiple regression calculation, we do like this. 1 minute, regression already selected, regression. Then here dependent variable, here you select the dependent variable, this dependent variable, dependent variable. Here you select the independent variable is price and income. So price and income here, price and income. And then you want the result where this delete this, you want to result here, you want your result suppose here. Suppose here you want the result, so here do okay, then do the okay, it will come. Calculation has come. This calculation has come. Okay, this calculation is come. This based on this. This is the Constant means intercept. This is the variable x and y. X is the price coefficient. This is the income coefficient. And all the values you have see here. Multiple R square, adjusted R, standard error, observation 10, regression, so all are given. Sum square, mean sum square, F value, DF, F significance, everything is T statistics, P value, all things are given. You can do the interpretation. It needs more time. Okay.